In the summer of 1956, inside a small room at Dartmouth College, a handful of researchers sat down with a bold idea that most people at the time would have laughed at. Computers were nothing more than giant calculators that filled entire rooms and did nothing unless a human typed in exact instructions. Yet these scientists believed intelligence itself could be engineered. They believed that if you broke down thinking into small enough steps, a machine could learn how to do it. They were more than optimistic. They fully expected that human-level artificial intelligence might be possible within a generation. They were wrong about the timeline, but they were absolutely right about the direction the world was heading. What began as a quiet academic experiment would eventually explode into one of the biggest economic shifts in human history. Today, artificial intelligence is no longer an academic curiosity. It is the core of a global race between nations, the foundation of new industries, the threat behind job losses, the engine behind new wealth, and the spark that is forcing governments to rethink everything from national security to education to infrastructure. AI has become the new currency of power, and every major country is scrambling to get ahead before someone else locks in an advantage that might last a century. To understand how we reached this point, you have to go back to the beginning. In the early decades of computing, machines could only follow rigid rules. They had no way to learn, adapt, or understand anything beyond what a programmer typed in. Researchers created early reasoning systems, logic engines, and something called the perceptron, which was a primitive ancestor of modern neural networks. These systems showed flashes of potential, but they collapsed under real-world complexity. Governments lost interest, funding dried up. The field hit the first of two devastating AI winters, periods where people stopped believing artificial intelligence had any future at all. The pattern repeated again in the 1980s. Companies spent millions building expert systems designed to mimic human decision-making. For a while, it looked like AI was finally useful. But these systems were brittle. They broke easily. They required endless updates. They couldn't learn from new information. Eventually, companies gave up on them, and the second AI winter began. For decades, artificial intelligence became a punchline, an overhyped field that promised the world and delivered nothing but disappointment. But beneath the surface, something important was changing. While symbolic AI kept failing, a different approach quietly matured. Instead of programming intelligence, what if we let machines learn patterns from data? At first, the results were unimpressive. The hardware was too weak, the datasets were too small, and the algorithms were too basic. But the world was about to change in ways nobody expected. First came the internet, then smartphones, then social media. Suddenly, humanity was generating more data every year than in all previous centuries combined. At the same time, the gaming industry accidentally created the perfect training engine for neural networks, the graphics processing unit. GPUs, originally designed for rendering video games, turned out to be incredibly good at the kind of math needed to train deep learning systems. And then came the breakthrough that changed everything. Deep learning began to scale. It turned out that if you fed these new neural networks more data and more computational power, they didn't just improve gradually, they improved dramatically. The turning point hit in 2012 when a neural network absolutely crushed a global image recognition competition. Overnight, deep learning went from an obscure academic topic to the hottest field in technology. Suddenly, computers could recognize objects and photos, understand speech, recommend products, detect fraud, and translate text far more effectively than anything before. Companies like Google, Facebook, Amazon, and Microsoft poured billions into AI research, building enormous data centers and hiring every specialist they could find. But the real explosion came in 2017 with the creation of the transformer, a new type of neural network architecture that could analyze and generate language with almost frightening flexibility. Unlike older models, transformers improved as they scaled. Give them more data, give them more compute, and they didn't plateau. They evolved. They generated insights. They began writing, summarizing, translating, interpreting, coding, analyzing, and in some cases reasoning at a level that shocked even their creators. This unlocked the era of generative AI chatbots that wrote human-like text, models that created photorealistic images, systems that wrote code, and algorithms that translated between languages with near-native fluency. This was the moment AI went mainstream. Businesses discovered they could automate enormous parts of their workflow. Governments realized these systems had military and geopolitical implications. Investors saw a trillion-dollar opportunity, and nations around the world understood they were standing at the edge of a new technological arms race. Today, the United States and China dominate the AI landscape. The United States leads in cutting-edge models, frontier research, and the design of advanced chips. China, meanwhile, leads in deployment scale, manufacturing capacity, and sheer volume of AI applications. The European Union has tried to carve out its own role through strict regulation and targeted investment, while also pushing to build its own AI infrastructure. Other countries, Japan, South Korea, India, the UAE, and Singapore, are racing to build their own footholds before the window closes. This isn't just about tech, it's about power. In the last few years, the United States has imposed strict export controls on advanced chips that China needs to train large AI models. China responded by accelerating domestic chip production and pouring billions into homegrown AI labs. Both countries now treat AI as a national priority, comparable to nuclear energy or aerospace in previous generations. Whoever leads in AI shapes the rules of global trade, national security, and economic growth. What AI is already doing to the economy is massive. For the first time in history, automation isn't replacing physical labor, it's replacing mental labor. White-collar professionals, analysts, writers, accountants, designers, call center workers, programmers, and administrators now face a new competitor that never sleeps, never takes a salary, and doesn't make human mistakes. Companies are breaking work into smaller chunks and handing many of those chunks to AI. Productivity rises, costs fall, and the job market shifts. Some roles disappear, new ones appear, and the gap between early adopters and everyone else grows wider every month. At the same time, AI is creating an entirely new class of economic infrastructure. Nations are building massive data centers, investing in new chip factories, and rethinking their electrical grids to support the enormous power consumption required to train large models. Entire industries will be built around AI auditing, safety, compliance, synthetic data, and model training pipelines. The countries that treat AI as infrastructure, power, compute, chips, education, and deployment will dominate the next era of global wealth creation. But the race is not without risk. AI creates enormous challenges: misinformation, deepfakes, cyber attacks, autonomous weapons, surveillance, and concentration of power in the hands of a few corporations and governments. Policymakers are struggling to balance innovation with safety, opportunity with stability, and progress with protection. Yet every time one side introduces regulations or export controls, the other side accelerates. Fear of falling behind fuels the entire cycle. In the end, the nations that win the AI race will be the ones that do more than build flashy demos. They will be the ones that integrate AI into manufacturing, logistics, agriculture, energy, education, and healthcare. They will be the nations that retrain their workforce, build the compute infrastructure, secure their chip supply chains, and use AI to strengthen the backbone of their economy instead of weakening it. And that brings the story back to you. Every economic revolution, steam, electricity, computers, created winners and losers. The people who learned the new tools rose to the top. The people who ignored them were left behind. In the AI era, the divide will be even sharper. The individuals, companies, and countries that adopt AI early will multiply their productivity. Those who don't will struggle to compete. The world is moving into an age where intelligence becomes a utility, something you can plug into like electricity, and the only real question is whether you learn to use it or get outpaced by someone who does. Back in 1956, those early researchers believed machines could learn to think. They were early to the party, but their vision is finally becoming real. The rise of artificial intelligence is not slowing down. It is accelerating. It is reshaping industries, shifting power between nations, and rewriting the rules of the economy. The question now is simple. How do you position yourself on the right side of the biggest technological shift in living memory? If you want to follow the economic changes sweeping across industries and nations, hit the like button, subscribe, and join us in the next video. The future is being built right now, and the people who understand it will be the ones who shape it.